So the question is evaluate the following limits using the basic laws and limit. So that's simply what we are saying, that when you have a function raised to power n, then the limit is simply limit of the function raised to power n. And limit of a constant is always a constant. That's what they're trying to tell you here. So one, they want us to evaluate limit as x approaches 9 of x. So what will this give us? That's 9, just direct substitution, the answer will be 9, okay? Yeah, good. And then the second one is limit as x approaches minus 3 of 14. What do we get as the answer to that limit? Why? Nimekuchanganya ni gani? 14 ni 14 too, just a number. Yes. Why are you getting 14 power negative 3? Hmm. 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 But you see now, Apple, there's no x power m. So if it was, that will be right if now, if you had, say 14 power x, is when you say now the answer is 14 power minus 3. But there's no x power n here. We say that limit as x approaches a of k is given by? As x approaches a. That's a constant multiple if there's an x. But Yapa 2 is the limit of k. So the answer will be? So the answer here becomes 14. So you know that limit as x approaches a of k is just k, okay? Yeah. So therefore, they are just trying to test your mind on whether you know that if you have a constant, if you define the limit, you get the same number. So that's the trick they are giving you in that problem. So the answer will be still 14. And then 3, limit as x approaches a half of x power 4. Do you use the rule of power? So the answer will be? A half. Correct. Yeah, that's just using the power rule, that if you have limit as x approaches a of x power n, you get a power n, okay? Good. And then so then you can simplify this as say 1 over 2 power 4, is this 16? Yeah, correct. And then the other one is given by limit as z approaches 27 of z power 2 over 3. So what? So still power rule, so we'll have Yes, you put it in decimal. Kapata ngapi? Yes, and so then don't delete the answer, then you would click in 27. Then raised power. Answer, yes, equals 9, correct. Ambayo sili hata bado ungefanya 27 ukisema raised power 2/3, unaweza andika kama 27 raised power third and then square. So raised power third is the cube root. So cube root of 27 is 3. So 3 squared is 9. But you need not to, so still by getting the power in decimal form, then saying base raised power, raised power answer, I get the answer still okay. Fine. And then the other one is limit as x approaches, as t, this is t approaches 2 of t power -1. Yes. So the answer will be, which is the same as, or a half, okay? Yeah, good. Then part B, the same thing. We are still applying this limit laws. So B, the first one is limit as x approaches 5 of, yeah. So jibu itakuwa nini? Yeah, so because you're going to have 5 raised power -2, which is 1/25. Eh? Yeah. So then Roman 2 is limit as x approaches a third of 3x cubed plus 2x squared. So x approaches a third of x cubed plus 2 limit x approaches a third of x squared. Yeah. Correct. That's our next step. Into power 3 plus into power 2, correct. So then third power 3 the same as, so this is the same as 3 times 1/27 plus 2/9. Don't know if you're able to see that. Yeah, so 3 into 27, 9. So it's like 1/9 plus 2/9. Patia ngapi? A third, because we are going to have 3/9, which is just 1/3. Yeah. Yes. Right? So if you want to use a calculator, for example, evaluating this this part, the first thing you key in 3, and then key in brackets, and then open bracket, then you key in 1/3. And then you close the bracket. And then you key in this button here, raise to. Okay? And then you key in 3. Then press equal sign. Should get 1/3 or 1/9. Okay. Okay. Good. So then now, try to follow those steps and see whether the answer is the same 1/9. Yeah, press 3, sawa. Then press into brackets. Then there's a write 1/3. Just kuna you key in 1, and then you key in that button in kuna A/B, and then in 3. Close brackets, yes. And then button in kuna raise to power. You can see the power. And then press in 3. Then press in equal sign. I think that's error, you are sure? Whether this is correctly or wrongly. So I told you, you click in 3, into brackets, 1/3, close bracket, raise, then 3. Yes, after writing the raise, pressing the raise button, then you press in 3. Sasa once close the bracket, unaweka raised power function button, and then unaweka 3. Yeah, so that's what you do. But then also, if you see that you can actually get confused, just do part by part. Like if part hiyo 1/3 qubit, then una multiply na 3, still bado utapata. So if you can't do all the steps in one, then you can just yeah. Yeah, that's better, so that we don't put all the steps together and then at the end of the day get an error. So just do one by one. Okay. Yeah. So then next one is, I think now you can Roman 3, 4, and 5, you can try them. Because itakuwa now, like the other one, itakuwa x approaches -1 of 3x power 4 minus 2x power 3 plus 4x. Sasa hebu niambie, what will be the first step? 3 power 4, sindio? And then minus 2 limit as x approaches -1 x cubed plus limit itakuwa hivyo. Is that what you wanted to say? Yeah, good. Then next step itakuwa 3 into -1 raised power 4 minus into -1 raised power 3, correct? Plus 4 into just -1, correct? Use your calculator and tell me the final answer. One, correct. Because this is going to just be 3 minus 2 minus 4. Plus 2. Yes. Yes. Mm. Mm. Yeah, that's good. That's good. That's me now. Mm. 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 Yes. Oh. Yeah, sasa yenye unakuwa na number then unakuwa na function ndio utafute limit yake. Yeah. Yeah. Mm. Mm. Oh. Oh. Mm. Okay. Yes. Yes. Oh. Yes. Mm. Yeah. Unatoa 3 nje kwanza then yes. Yeah. So numbers unatoa nje kwanza. Yes. Mm. Oh. I think now with a lot of examples, then the things becomes much familiar with it. Sasa hiyo mm. So then now hii ingine nataka uniambie tena tunaandika nini? Limit as x approaches 8 of 3 x power 2 over 3 minus 16 x power minus 1. So what is the first step? Limit okay. Minus 16 limit x to 8 correct. Sasa step inafuata 3 8 power 2 over 3 mm. 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 -1 okay. Sasa nipatie jibu hiyo ni nini? Work it out and tell me the answer. $62. Sure. 62 kweli, inafika 62. Abu nipatie answer to the first part. Nipatie answer to the first part. Yote. Hii. Abu niambie steps umetumia. You kidding? Mm. 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 Sasa the mistake. Sasa unajua nikwambia hiyo sasa ukitaka kwenda hivyo unaandika sasa kama hujapata decimal kwanza unaandika 3 andika 3 into 8 raised power into brackets. Yes. 2 divide button division, okay? 3 then close brackets. Pata 12. Sasa if you have not gotten the fraction into decimal, unaweka raised power and then you include bracket, then you just say the numerator divided by the denominator is equal to a normal division sign. So that's when you get the correct answer. Still the same thing. So ukiwema 2 divided by 3, alafu kuwa na hiyo jibu. Okay? And then unasema 8 raised power answer. Raised power answer. As I say, you are that's already even if you use the decimal. So this is 12 minus 8, this minus 10 minus 2 equals to 10. Confirm that the second term inakupatia 2. Able to see where the 2 is coming from. Just use your calculator to evaluate that part and see that the answer is 2. Correct. So yeah, unaiweka hiyo fraction kwa decimal ndio upate correct answer. Usipoweka kwa decimal unapata wrong. Yes, or if you want to use it the way it is, unatumia division sign. Numerator divided by the denominator, unaiweka kwa bracket, cha raised power ndani ya bracket, sawa? Yeah. So the last one for number 4 is limit as x approaches to x plus 1 3x squared minus 9. Sasa what will be the steps? Hii ni which rule unakuwa applied hapa? Product, you kuna product. So kutakuwa na limit of the first function x approaches to times limit of the second function. Okay? So the first one inatupatia nini? Mm. 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 Correct. And then the other one? 3 limit approaches to of x squared minus correct. So now ya kwanza itapatia ngapi? 2 plus 1 into squared minus 9. Limit of a constant is the same constant, okay? Yeah. Sasa bracket ya kwanza 2 plus 1, 3, and then 2 squared is 4. 4 times 3, 12 minus 9. Sure. 3. So that will give us 9, correct. Haya, sasa so, question 5 Roman 1 unaweza fanya kama hiyo tumefanya hiyo, si ndio? Na Roman 2 Roman 3 it's just the same way you do that. So this is what you do. Una limit as z approaches 9 of square root of z over z minus 2. So hii ni quotient rule. So kunakuwa na limit ya juu of root z over limit ya chini of z minus 2. So we'll have the same as limit of root z as z approaches 9. Ya chini tutaandika aje? Limit z minus sasa hapa tuna just substitute penye kuna zaidi na maanisha unaweka 9, okay? So itakuwa root of 9 over 9 minus 2, correct. Root 9 is the same as 3 over 7. So that's what we do. Yeah. Finish the remaining for question 5, isn't it? Tuende which question number yenye iko tofauti sasa. Let me help you to unaona question let tuende question 6. Question 6 part B. Tufanye 6B, okay? A little bit different from these others. Ni bado na test kwa hizo loss tumefanya. Kwa nasema upewa limit of f of x as x approaches 6, jibu ni 4. So find limit part 1, limit as x approaches 6 of f of x squared. Hapo na test which law? Power rule. So hii tutaandika kabla tuandike 4 tunaandika aje hiyo limit? So tutaandika hivi, tunaweka hapo hiyo power alafu tunaandika limit ndani, okay? Yeah, so that's what you do. So then jibu inakuwa why mbona 6 squared? Unaona ametuambia penye kuna limit of f of x as x approaches 6 naweka 4. So itakuwa 4 squared. Okay? 16. So the other part inawatuambia to evaluate limit as x approaches 6 of 1 over f of x. So the question is, wanajaribu kutest which law here? Quotient, because kuna kitu inakaa kama fractions, ndio? Kama wanafanya division mahali. So this is a really quotient rule. So tutaandika this is the same as limit ya juu as x approaches 6 over limit of the lower function f of x as x approaches 6. Ndio? Na limit ya 1 as x approaches 6. Ya juu inatupatia nini? One, because it's a constant, okay? Yeah. Na chini. Oh, you already washatupatia kwa question yenyewe, si ndio? So jibu inakuwa tu a quarter. Okay? Yeah. And then Roman 3 wanataka tutafute limit as x approaches 6 of x square root of f of x. Sasa hapo wana test which rule first? Kabla ufike root loss kuna yenyewe for wanze nayo. Kuna constant hapo. Sasa constant multiple rule kama ungekuwa na x root f of x ingekuwa hivyo. Hakuna constant hapo. Hii first wana test product rule. Unaona kuna x na kuna root of f of x. So ndio kitu ya kwanza unasema hii ni limit ya x and then we multiply by limit ya square root of f of x. Okay? So ya kwanza hapa ni product rule. So this is this dot here. Product rule. Because x is a function and then f of x is also a function. So that's the first thing that you need to apply. So unakuwa na limit as x approaches 6 of x, but then now hii square root, hii limit ya square root ni kama square root ya limit yenyewe, si ndio? If you remember that ulikuwa na root ya function, unaingiza tu limit ndani alafu root inakuwa nje. Okay? Yeah. So limit ya x as x approaches 6 will be y4. Sasa nataka tudili na hii kwanza. 6 ndio tuna replace penye kuna x tunaweka 6 ndio times hii itakuwa square root of 4. You guys already hapa ndio limit ya f of x ndani, okay? So root 4 is the same as 2. So jibu itakuwa 12. Good. Unaweza kuwa na
6C, I know the first one you went to.
correct. Product rule in the first one. So now once you know that one, then you will be able to get it. Because now the first thing is to know to understand which rule are you supposed to apply. So that will be product rule because then yes.
Yes.
And correct. Just a minute. Hello, mwalimu. Mzuri sana. Yes. No. Yes, yes. Sawa, sawa. Tuesday, sawa, no problem. Sawa. Okay, no problem. Sawa. Okay, okay. No problem. Sawa, sawa. I'll organize so that I send you the situation. Maybe vijana wanaweza angalia during the weekend. Yes. Sawa, asante. So, sorry for that. Yeah. So then you see even impatience. Or should you repeat all of it, or maybe I structure it? Good. Yes. 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 Yeah. Yeah, and then also we'll review it maybe in the next session. Yeah. Sasa number 7 nasema evaluate the following limits. Sasa hapa talk about the limit process. Limit process. So these are now where they are testing methods of evaluating limits. Methods of yes. 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 There's a problem. Yeah. Yeah. Or mm, 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 mm. So the first thing unajaribu kuweka directly uone kama 0/0, then unaangalia kama can you factorize ama can you rationalize vitu kama hizo, sawa? So kwa methods of evaluating limit kuna hizi. So let me just restate them. There's what you are saying. So the first thing is what we call direct substitution. Na direct substitution ni kama hizo zenye tulikuwa tunafanya. Penye kuna nini unaweka tu penye value where x is going to in the function, penye kuna x unaweka hiyo value. So that's what we call direct substitution. Direct substitution. Na every time unaanza na kutest na hiyo kwanza, kama haifanyi kazi ndio unaenda kwa hizo. So substitution. So if direct substitution itakupatia what you are saying, that things like 0/0 or infinity, hapo ndio sasa think of a different method. Okay? Sasa ingine ni factorization. Ingine ni rationalization. Ingine ni what we call L'Hopital's rule. Sasa L'Hopital's rule itafunzwa kama mmemaliza differentiation. So the L'Hopital's rule will be applicable once you have understood different methods of differentiation, because in a test how to evaluate limits, which on direct substitution we get 0/0 or infinity using concept of differentiation. So we'll discuss them later on. Okay. So what was done in class majorly was to apply this first three. This other one is later after differentiation. Okay. Yeah. So we start. Let's go to 7a. Metupatia limit as x approaches 4 of x squared minus 16 over x minus 4. Okay. Sasa unaona hapa ukisema direct substitution inamaanisha penye kuna x tunaenda kuweka 4. Because unatuambia x is approaching 4. So it means that now we directly substitute where, assuming that you've already reached that point. So utakuwa na 4 squared minus 16 over 4 minus 4. So 4 squared is 16 minus 16, 0. 4 minus 4. So you see this one is what you are getting undefined thing. Okay? So when you unapata direct substitution nakupatia 0/0, hapo ndio sasa we will think of these other methods, either factorization ama rationalization. Na ukitaka kujua penye unafanya rationalization, utaona vitu zinakaa kama SATs. Sawa? Yeah, SATs, things which look like SATs in your rationalization inatumika. Now once you get this like these polynomial functions, then your factorization ndio utatumia. So then now we know that you need to know this. Ukiwa na any arbitrary two values a and b, 1 a squared minus b squared is the same as a minus b times a plus b. Unakumbuka hiki kitu walifunza primary, not primary, high school. Yeah, inaitwa difference of two squares. Sawa. So it can always help you to actually to manipulate these things to know how to factorize. So ukiona that there's a number yenye imeandikwa kama ya kwanza ni square na kuna minus sign na the other part is also squared, then you can always write it as product of these two, a minus b, a plus b. Okay. Kuna also a difference of two cubes. Ukiwa na a cubed minus b cubed, unaandika a minus b, and then you multiply by a squared plus ab plus b squared. So that's also a difference of two cubes. It's also an expression that can help you to simplify or to do some factorization, then reduce the problem into solvable form. Then kuna another identity, a power 3 plus b power 3 ni a plus b into a squared minus ab plus b squared. So keep these three identities. These are most in some of the problems involving factorization. They can help you to know how to do the factorization of the expressions to reduce it so that usipate 0/0. So yeah, to our problem, unaona kuna x squared na kuna minus 16. And 16 inazaliwa kama square of which number? 4. So which means the numerator inaweza kama x squared minus 4 squared. Okay? As unaona sasa, it will be like looking like the first case, a squared minus b squared. Okay? So hii itakuwa factored like x minus 4 into x plus 4, correct? Sasa hiyo this is the factorization tutatumia kwa hii numerator hapa. So unaandika that the limit x approaches 4 of x squared minus 16 over x minus 4 is the same as limit as x approaches 4, x minus 4, x plus 4 divided by chini is x minus 4. Hata kuweka brackets hapa hakuna mistake. Oh. Sasa what can you say about those new expression? Kuna kitu naona iko common inatoka x minus 4, x minus 4. Yeah. Yeah, hizi ndio na cancel zote hizi. So nabaki na limit as x approaches 4 of x plus 4. Yeah. Sasa hii inapatia nini as our final answer? 8. Kwa tutakuwa penye una directly substitute penye kuna x weka 4, itakuwa 4 plus 4 which will be 8. Yeah. Sasa hapo hiyo swali that limit is solved by oh, sawa. No problem. So once you are done, you let me know. Good. So we go to problem 7B. So Roman 2 inatuambia limit as x approaches 3, x squared minus 4x plus 3 divided by x squared plus x minus 12. So kitu ya kwanza, before you start to think of factorization ama rationalization, weka kwanza x values uone kama inapata jibu ama inapatia 0/0. Sawa? Yeah, sasa we direct substitute first to see what is happening. So kutakuwa na 3 squared minus 4 times 3 plus 3 divided by 3 squared plus 3 minus 12. Sasa hebu tumia calculator uniambie hii inatupatia nini? Oh, because say 9 plus 3, 12 here. So this is 0. Here in is 0, sindio? So undefined. So which means that then you always pata your limit by direct substitution. So what we'll do, we are going now to factorize. So unaandika n to main numerator, kuna x squared minus 4x plus 3. So ask. Mm. 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 Mm-mm. You don't conclude does not exist. You don't conclude before now. You confirm that you can factorize and simplify. Sasa kama if we will not be able to factorize na tupate things which are cancelling in the numerator and denominator, ndio tuta conclude hivyo. But kabla tufanye hivyo, then we don't conclude. Tufanye factorization kwanza. Yeah, so I understand what you're saying, that sometimes a quadratic expression may not be factorized. It is possible. Okay? So if you get this a case whereby now, like for this case, kama x in approach a number now, we can't factorize any of them. To give us things which are cancelling out, to remove this and define case of 0 by 0, we say that's not exist. Sawa. But before ufike hapo, hakikisha kwamba umejaribu na factorization haiwezekani, but don't conclude before now you try factorization. Okay? Yeah. So hii hapa, hii ni kama quadratic expression. So these are quadratic expressions. So product ni nini? 3. Sum. Correct. So what are numbers which are giving us sum of -4, product of 3? Okay, confirm them. Kwa -1 atatupatia product ya 3. Atatupatia product ya -4. Na hapa product yetu ni 3. So check other calculation. Ya kwanza ndio product 3. -3 and correct, -1 and -3. So tutakuwa na x squared minus x minus 3x plus 3, si ndio? Tukitumia hizo namba mbili kuandika hiyo middle term. Yeah, so then now we do the pairing. Tunachukua ya kwanza na tunachukua ya pili, sawa? So ya kwanza common ni x into x minus, correct. And the next one tutakuwa common hapa ni 3, si ndio? Into x minus 1. Remember hizi bracket mbili zinapaka zikuwe zinafanana. And if you try to open this one, utaona hii -3 na -1 bado yapata +1. So hii hapa inamaanisha we take x to join to this -3 na tunachukua hapa one of the x minus 1. Si ndio? Yeah. Sasa hiyo ndio factorization ya numerator. Tuende kwa denominator. Denominator ni x squared plus x minus 12. Sasa hii inamaanisha product ni -12, correct? sum coefficient ya x ni 1, sawa. Then what are the numbers? -3. Correct, -3 and 4. Those numbers are the one that will give us this combination. So that tunatumia those two numbers to rewrite the middle term. So kunakuwa na x squared minus 3x plus 4x minus 12. And then we pair the first two, pair the last two. Okay? So tutakuwa na common here is x into x minus 3, isn't it? Now what is common in the next pair? Mm. 4 is common. So 4 into x minus 3. Okay? So tunasema x inajoiniwa na plus 4 na pick one of the x minus 3 brackets. So yeah, so which means then now we have all the factorization of both the numerator and denominator. So to now say limit as x approaches 3 of we had x squared minus 4x plus 3 divided by x squared plus x minus 12, itatupatia limit as x approaches 3. Sasa juu tumefactorize tukapata ni x minus 3 times x minus 1. Chini tukapata ni x plus 4 times x minus 3. Is there any common x minus 3, x minus 3, sindio? Yeah, na cross those two. So tutakuwa na limit as x approaches 3 of x minus 1 divided by x plus 4. Sasa hapo once you have done the correct factorization, ukifika hiyo once you cross things which are common, when you do direct substitution now you always get the correct answer. Utapata 0/0 tena. It's always the case. Ukifanya correct factorization, if it was a factorization problem and you close these common brackets, then your direct substitution will always work. Itakuwa 3 minus 1 over 3 plus 4. So utakuwa na 2 over 7. Okay? Yeah. Then kuna hiyo ingine inasema limit as x approaches pi over 2. So remember pi in terms of angle ni 180 degrees. Ukidivide na 2 inamaanisha 90 degrees. Sawa. Ndio next 7 kama 3 from 3. Able to see it? Okay. Sasa Mwalimu alifika kwa nini? Mwalimu alimaliza limits mkaenda differentiation, si ndio? Sasa hizi pitia zote nyinyi paka pia msome wenyewe. Yes. Yes. Mwalimu anajua that nyinyi pia mpaka mjisomee. Sasa this does not make like this. Bwana anaseti kitu kama hii kwa mtihani. University watu wafanyiwe kila kitu. Yeah, so let's see how we discuss it. I was explaining that when you are dealing with trigonometric functions, pi inamaanishanga 180 degrees. Sasa mtu akisema pi over 2 inamaanisha 180 degrees divided by 2 ni 90 degrees. Sawa? Sasa hebu jaribu kuweka what is tan 90 degrees? 90. Math error, so that is infinity, is not defined. Ukichora hiyo graph ya tan at 90 ni asymptote, hizi guza 90. So hiyo ni infinity. Na sec 90, sec inamaanisha 1 over, I hope you are told this, this other trigonometric ratios that kuna kuanga na tan. Let me just start with the basic. Let me remind you some things on basic trigonometric functions. Ukiwa na a right angle triangle, inakaa hivi. If you have this, believe that this is a right angle triangle. Sasa ukiwa hapa na theta, if I call this angle theta, na niite hapa B, niite hapa A, niite hapa C. So this is A, C, B. Oh. So in this triangle, I can define what I call sine theta, which is usually opposite over hypotenuse. So nakumbukanga hii kitu mlifunza siku chochote hii ama sokatoa. Yeah. So then sine is opposite over hypotenuse. Okay? And then cosine ni adjacent over hypotenuse. And then tangent ni opposite over adjacent. Okay? Yeah. Sasa kwa hii triangle, sine theta itakuwa opposite, which is A, over adjacent hypotenuse, which is C. Okay? And then kuna what we call cosine. Cos itakuwa, which is B, over, which is C, sindio? And then tan is, which is A, over, which is A over B, sindio? Haya, sasa kwa hizi kuna others, tukitafuta reciprocal hizi tunapata other trigonometric ratios. So what we call cosecant is 1 over sine. So which will just be C over A. Sasa in full tunaandika, in full inaandikwa cosecant. Inaandikwa hivi, cosecant. Yenye tuna abbreviate kama cosec. Sawa? And then ukisema kuna ingine inaitwa secant, sec theta ni 1 over cos. So C over B. So secant inaandikwa hivi, sec. And then kuna yenye inaitwa cotangent abbreviated as cot, which is 1 over tan. So itapatiwa b over a. So in full inaitwa cotangent. Kuna kuanga na 6 trigonometric ratios. Kuna sine, kuna cosine, kuna tan. And then we have the reciprocal of sine is called cosecant, abbreviated as cosec. And then the reciprocal cosine, it is called secant, abbreviated as sec. Reciprocal tan is called cotangent or abbreviated as cot. So, yeah. Sasa kwa hii hapa, ukitaka kutafuta the value of secant of x, the same as just finding 1 over cos x. So hapa ukitaka kutafuta sec of pi over 2 or sec of 90 degrees, fanya 1 divided by cos of 90 degrees. One inapatia nini? Sec means 1 over cos. Yes, of course 9, yes. So unapata jibu gani? Math error, bado ni infinity is not defined. So so these are another poor case. Infinity over infinity. Sasa direct substitution cannot work, okay? Sasa what we do in this case now, you try to play with this tan and sec. You represent them in terms of cosine and sine. Uone kama kuna things which will cancel out, okay? Ask. Mm. 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 Yes. Means 180 degrees. Yes. Mm. Mm. Maanisha is not defined unaweka infinity. Yeah. So and in not defined tunatumianga hiyo infinity symbol. Mm. Sasa so there's some we will also get when we'll also be discussing about limits at infinity, even not necessarily trigonometric functions alone, but you can also find algebraic functions when x is approaching infinity. You'll also So now hapa kuna limit as x approaches pi over 2. So hii tan inaweza andikwa kama you know that tan theta is the same as sin theta over cos theta. Yeah, hii walifunza high school, okay? Tan is the same as sin over cos. Sasa hii tutaandika kama penye kuna tan tunaandika sin theta over cos theta and then times you see this inaweza andikwa kama tan ukiandika tan x over about there I'm changing the variable here. So this is just x. Nikiandika tan x over sec x, so this an x, this an x. Ni kama tu nikiandika tan x na ni multiply na 1 over sec x. I think you should be able to realize that those two are the same. Ni kama nikupatia a over b is the same as a times 1 over b. Sindio? Sasa hii ninaandika kama tan x which is the same as sin x over x times 1 over sec x. So now what is 1 over sec x? sec x in terms of, so kama tunasema sec peke yake ni 1 over cos. So tukisema 1 over sec kabla to replace 90, replace the where x is going to. I just want 1 over sec is the same as which ratio? So remember sec x is the same as 1 over cos x. So nikisema 1 over sec x itakuwa nini? It's like I'm getting reciprocal on both sides. Cos, sindio? Itakuwa cos. Sasa unatafuta reciprocal on the other side. So 1 over sec x is the same as cos x, sindio? Yeah, so hapo we multiply by cos x. Okay? Sasa hapo tunaona things will, some things will cancel out. Cos and cos, sindio? Yeah. So which means then we'll have this to be limit as x approaches pi over 2 of sine of x. Yeah. Then that's even a funny direct substitution. What is sine of pi over 2? It's like I'm asking you, what is sine of 90 degrees? Cosec. Hapa tushapata, this is the final answer now. So sine of 90 degrees. So tushamaliza ku replace. Yeah, sine 90 degrees ndio the same as sine of 1. So jibu inakuwa 1. Okay? Yeah. Huh? Yes, they are there. They are there. So I'll share some. I'll share the link. Yes. Yes. Hii inakuwa vizuri. One by one. Yeah. Sasa nataka with that in mind, I want to explain also other I want to skip the next problem. Nimefanya tena another example ya kimbele. I want you to go to question 30. Yes. Question 32 sawa. Yeah. Sasa you have to know this as some standard limits. So ya kwanza tunasema limit as theta approaches 0 of sine theta over theta is 1. Then number 2, limit as theta approaches 0 of 1 minus cos theta divided by theta is 0. Limit as theta approaches 0 of cos theta minus 1 over theta is also 0. And you are very senior to know that nikitoa theta niweke x kila mahali pia they still have the same meaning. They will still be the same thing. Like nikuuliza, what is the limit as x approaches 0 of sine x over x? You should be able to know that the answer is still 1. Yeah. So the role of theta and role of theta and x will just be the same for that case. And ikisema limit as x approaches 0, 1 minus cos x over x, bado utapata 0. So hata nikichange now nikisema limit as x approaches 0 of cos x minus 1 over x, pata 0. Okay? So the thing is that now, you should be able to see that now. Kama hapa nimetumia theta throughout na nipata AGB, still the same thing hata nikichange another variable. Nikiweka k hapa, k, still have the same thing. Nikiweka m, bado nitapata the same thing. Okay? Yeah. So, for example, if someone asks you, evaluate this is just an arbitrary example. Limit as x approaches 0 of sine 2x divided by x. Are you there? Sasa hivi tutafanya hivi, unasema we use what we call we make use of a change of variables. Change of variables inamaanisha sasa I want to create the same limit, but nitumie something different that will enable me to use some of these standard limits that you make up, okay? Yeah. So here, assuming singekuwa hapa na tu ningekuwa tuna x, jibu ingekuwa nini? Hii tu ingekuwa of sin x over x, jibu ingekuwa nini? Over x. From the identities nimekupatia, jibu ingekuwa 2 1, sindio? Yeah, that's it, because that will be a standard limit. So what makes us now to be in trouble is because of these two. Sawa. Tu ndio shida hapa. Kama hii tu isingekuwa hapa, jibu ingekuwa 2 1. Yeah. So now we fix that part to one variable. Tunasema let theta be the same as 2x. Sawa. Or you can say let u be 2x, or any letter that you want to use. Fix equal x, equal 2x. Sasa ukifanya hivi, inamaanisha x peke yake itakuwa nini? Kama theta ni 2x, what is the value of x? If you make x the subject. Correct. Na unapata theta over 2, sindio? Yeah. Good. Sasa now, let's see. As x approaches 0, then theta approaches which value? Na kama nakuuliza, nikiweka x for 0, what would be the value of theta? 0. Theta itakuwa 0 tena, si ndio? So which means as x approaches 0, bado theta ina approach 0, si ndio? Yeah. So then now we rewrite the whole now this limit in terms of this new variable theta. So inamaanisha limit as x approaches 0 of sine 2x over x itakuwa limit now sine where there's 2x tuna put theta, si ndio? And then instead of saying x approaches 0, we say theta approaches 0. And then divided by, it was divided by x. Now x tumepata jibu ni theta over 2. That's this new limit iko purely in terms of the new variable theta. So, yeah. And then you know that, so sine theta divided by theta over 2 is the same as sine theta times reciprocal here, theta over 2, so it's the same as 2. Remember sine in affect theta peke yake. Sasa usiandika hapa to sine of 2 theta. Hii tu unaweka kabla word the sine, okay? Yeah, so 2 sine theta divided by theta, si ndio? So which means then sasa hii unaweza andika kama limit as theta approaches 0 of 2 sine theta divided by theta. Na tunakumbuka zile constant multiple rule ya limit. Sasa hii tu tunaweza toa nje. Naweka 2 limit as theta approaches 0 of sine theta divided by theta. Sasa hiyo limit itakuwa nini? What will be the value of sine limit as theta approaches 0 of sine theta over theta? Tushapata hapa. I've told you that these are standard limits. That kama unapata limit ya sine theta over theta, if theta is going to 0, it is always 1. Na kama unatafuta limit ya 1 minus cos theta over theta, when theta is going to 0 is 0. Similarly to this. Sasa hapa jibu itakuwa nini? 1 times what? Which will be? So inakuwa 2 times 1, which is just 2. Sasa jibu ya hiyo limit inakuwa 2. So, yeah. Haya, nataka ujaribu sawa. Should I scroll up or you are okay? From, have you written this? Okay, so okay, fine. So let me want to scroll down. Okay. Okay. So ukitaka chini then tell me to scroll down. Okay. Hadi wapi hapo? Hapa. Hapa. Fine. Hata hiyo ni page ya mwisho. Sasa hapa nilikuwa na this part here. Hapa tu I was explaining how to do that. So ina flow hivi. These are the parts now. You see the same way we gave the two expressions for cosine. Pia bado unaweza ongeza tu hapo another one kwa sine, bado ukiwa na limit as theta approaches 0. Ukiweka theta juu na uweke sine theta chini, bado ni 1. Hata unaona hapa hata ukitumia sine theta sin theta over sin theta, if theta is approaching 0 then bado ni 1. So maana there are two, nimekupatia two versions za cosine. Kuna 1 minus cos na kuna cos minus 1. Cosine hata ukisema theta iko juu na sine iko chini, bado utapata 1. Okay. Good. So then now, can you let me do an okay? Let me do now. And then I will now. Let me give another one. I'll tell you x 0 of sine 9x over sine of 2x. So this one we are making use of this standard limits. Sin theta now, cos sine of theta over theta when theta is approaching 0. Now, so all these standard limits napeana hapa are the one that can help you to evaluate problems involving cosine and sine when the variable is approaching 0. So cases whereby you approach pi over 2, it will depend on the nature of the problem. So hautatumia these identities. Like the other one, tuna reduce the trigonometric part and then tunaona how we can express it in terms of other trigonometric ratios zenye zinatupatia either infinity over infinity ama 0 over 0. Yeah. So kuna ingine hapa. This one you have to play it in a smart way. So tunajua if we have limit of sine theta divided by theta as theta approaches 0, jibu ni 1. Tukuwa na limit as theta approaches 0 of theta over sine theta, jibu ni bado ni 1. Ndio? Sasa kitu tutafanya hapa, tutaandika na unajua if someone gives you a fraction a over b, unaweza andika kama a times 1 over b. Ndio? Yeah. Sasa let's split this limit in that form. Because inakaa kama fraction a over b. Sawa? Sasa tuandike limit as x approaches 0 of sine 9x times 1 over sine 2x. Sawa? Hapo unaona hiyo tujachange swali in the same question. Because okay, multiply bado utapata tu what you have, ndio? Yeah. Just now it's like I'm writing in terms of product of two numbers, okay? Yeah. Sasa bado kuuliza nini yafanye tu hapa chini if I was to put yenye itatupatia standard limit ya 1. Kama hapa niko na 9 sine of 9x, namba gani yafanye hapo kwa hii bracket so that hii part yake ni bracket? ipate 1. Not just 9 but 9x. Ndio sasa tunaona tumesema hapa theta, okay? So nikiweka hapa 9x itakuwa hii itakuwa jibu yake, ndio? But sasa unajua nikiweka hapa 9x na maanisha nimechange swali yangu, ndio? So that now sasa nischange swali, I can say I multiply huko juu niweke 9 over 9x. Tunaona nikiweka hapa 9x na 9x nyingine niweka hapa chini, kama nimemultiply hii everything in a 1 na 1 itachange swali. Ndio? Haya, good. Na sasa kwa hii box hapa unaiona hapa juu, hapo yafaa tuweke nini ndio tupate tena limit yake iko 1? Yafaa tuweke 2x kwa sababu tumesema limit of theta over sin theta as theta approaches 0 tupatia 1, ndio? So tukiforce hapa ikuwe 2x tutakuwa tumejua jibu ya hii kitu, ndio? Na sasa tukiweka hapa 2x na maanisha tunacheza jibu yetu wenyewe. Ndio sasa tusikue tunachanganya tu divide tena na 2x. Ndio? Kwa kuweka 2x hapa hakuna kitu kinachange kwa sababu it's like we are multiplying everything by 1. Multiplying a number by 1 does not change the value. Ndio? Yeah. So which means then now we are going to split. Remember everything that nimeandika hapa na original thing is zinafanana. Only that nimeandika hivi so that I get a structure which can take one of these standard forms that will be able whose limits are reciprocal. Okay? So then tasema this can be written as limit as x approaches 0 of sine of 9x over 9x times 2x over sine 2x. 9x nikidivide na 2x, x na x zitaenda, si ndio? So nitakuwa tuna 9 over 2. Good. Sasa I will now, so using properties of limits nitatoa 9 over 2. So nikuwe na 9 over 2. Then nitakuwa na limit as x approaches 0 of sine 9x over 9x na multiply na limit as x approaches 0 of 2x over sine 2x. Ndio? Hapo tumetumia tu the product rule ya limits, ndio? Yeah. So limit ya kwanza itakuwa ngapi? Hii. Tutapatia ngapi? Hapa to replace x. Remember, if you replace, you get into trouble. That's why we have the standard limits. That sine theta over theta, as theta approaches 0, it gives you 1. Takupatia 1 because it's taking the structure of the standard one. Sasa hapa jibu yake ni 1. Hii nyingine pia itatupatia 1, ndio? So which means then this is as good as just saying 9 over 2 times 1 ambayo jibu kwa 9 over 2. Yeah. So please don't say that now. So if inakuwa tu rahisi hivyo tutasema ati limit as x approaches 0 of sine 9x over sine 2x, ati tunakuja tu tunasema the word sine tunaanza ni hapa. Sema tu sine toe sine toe x toe x toe tabaki na 9. That's not how you show the answer. Yeah, please. The answer will be yes 9 over 2, but please you show it. You play with this identity to party. Not just now. This actually is this. Yeah. So the answer will be 9 over 2, but this is how you show it. But when I jaribu kusema, you try to rewrite what you have been given in such a way that be obtained from these standard limits. So I want to stop there. You can apply the same thing. Okay, good. Yes, we can also have another session. But of course, these are the- Sasa let me nitakwambia if it's possible tunaweza ifanya after maybe from 5. From 5 you actually I have a class in Nairobi from 2. Na asubuhi pia niko na so maybe I let you whether we can do it from 5. If it doesn't work then we'll still agree because we have to meet before. We'll have one session to meet before Patane Monday. So yeah, so we'll organize either after 5 tomorrow, if there's any change, we'll agree and then see when to meet. Yes. Yeah. Mm. Yes. Yeah, there are many. I think I can try to I'll send you some titles. There are many books with the calculus stuff. So I'll try to check them out and then share the titles. Okay. Have a good evening. Okay.